Okay, howdy. My name is Arjen, and I've been doing MySQL stuff for a long time. I used to work for a company you might have heard of called MySQL. I was employee number 25, and that's a while ago now. I run a company called OpenQuery these days, which does MySQL services, but not quite the way many other companies do. That would be boring. So I'll tell you today about how we work, not to show you our services, that's not particularly interesting, but because it might actually save you some money, because you can do it yourself, whether you ask us for help or not, because we figured out how to do things cheaper and in some cases differently from what you might have heard. Okay? One of the main things that we don't do is emergencies. And that actually originated from a talk I did here for Linux users of Victoria late 2007, I think it was, which was kind of a little experiment, and it worked out really, really nicely. I got such a good response to that particular talk that I thought, well, I'll try that in my business. And well, I'm not going to repeat what's on there. You can look for yourself. The advantage for my company is that I have a life, and I like to actually have it at night, at 2 a.m. I don't want to have the phone ring. On Saturday and Sunday, I don't want to have the phone ring. And I have people working for me who actually have that same opinion. So my pool of talent that I can choose from with engineers is actually larger, because I can have people working for me who don't actually want to work for a number of other companies. So that has actually served me quite well. You get a different type of person, really, and that's worked out rather well. But yeah, as you see here, emergencies are just a pest. Some companies believe they're unavoidable, and I think they're wrong. It's a business process thing, and in some cases the businesses are stuck to a degree that they create emergencies, but that doesn't mean that they're unavoidable. It's a different thing. So, why? As I mentioned, my life. Top left is my daughter. I now have a lovely girlfriend as well, and through the girlfriend I acquired a tribe, so there's 3 more kids. So I need more and more time there rather than somewhere else, you know. That's much more fun than databases. You might think, you know, I'm a geek, but that's much more fun. So there. So what do we do about it? We prevent the emergencies. It's no use being the fire department that doesn't prevent the house getting on fire, you know. So we want to prevent the house being on fire to begin with. That's the idea. Now, computers are really good at failing. And anything to do with computers is good at failing. They will fail. It's not a matter of if, it's a matter of when. So building things in such a way that it will never fail, an individual server or an individual file server, virtual machine or whatever, it will not happen. For instance, just to compare from some people who have a clue about both scaling and high availability, or at least resilience, a company you might have also heard of, Google, they have 2 basic rules. Rule number 1 is everything will fail, and rule number 2 is keep at least 3 copies of everything. And it seems to work fairly well for them too. So they don't say things need to be highly available, they will just say everything will fail. And they take it into account. So they have lots of copies of everything and make sure that when stuff fails, the system as a whole, which is what we see from the front end, still works. And that is the kind of thing that I've been looking at. So insurance, like, you know, service level agreements, I don't give service level agreements. I sometimes have a corporation asking me for one, and it usually, the discussion stops at the point where I say, well, look, you're sending me this amount of paperwork. I am not qualified to actually judge that, so I'll need to have a lawyer judge that, and are you going to pay for that time? And then they start cringing a bit and said, yeah, no, let's not bother. So we work on a best effort basis, and that works rather well. I don't want to be, let's say, the blame bunny when something goes wrong, because that again is an excuse for a company to not do things the right way. And it doesn't help them, because let's say, how many people here with a hosting provider that provided you with an SLA saying what the uptime will be? Yeah? That's a fair number. Okay, so when the whole thing fails, what will you get? Anyone? What are you going to get? Out of the contract. You get out of the contract. That is wonderful. Does that? Okay. Anyone else? Anything else? Does anybody get money?
If you're big enough.
If you're big enough, which means you don't get money.
If you go to someone like IBM or whatever, you can get paid a lot of money per day of failure or whatever.
Okay. Okay. Now, so let's assume that you run this important site that that really needs to be online, and you're offline for a day. You now have a dead business and a stack of money. It still doesn't help. It really, really doesn't help. But that's my take on it. But even from the business perspective, I don't think, that money doesn't save your business. It's after the fact. You really must make sure that it doesn't go offline to begin with. And the insurance policy doesn't cover it. And the way I figure it, the engineers that have to keep the stuff running, they don't get judged on the SLA requirements. They get judged on something else that's internal to the business. It's not directly connected. So they might get fired over the whole incident, but they still haven't kept your system online. So it doesn't help. So what we do is something that looks like that. Someone was asking me what my company did while I was having dinner about 2 years ago in Wellington, and I looked around me in the restaurant and I saw that set of lights. And as you can see, one of the lamps is not working anymore. Now, the restaurant didn't need to be evacuated, shut down for the light. You know, you laugh about that, but it still works as a whole. You know, there's enough light in the room, it works. And that's exactly what we're looking for. We know that computers will fail, but when one fails, the system as a whole still works. The function of this is not that each individual light works. The function of this is that there's enough light in the room. Of course, it looks pretty because you have that set, but there's a factor of redundancy and resilience in there. That's the idea. So that you will find that picture actually on the front page of OpenQuery because I think it describes the idea rather well. We know that failures happen, but they're not emergencies. So one of the things that, of course, is really important, make sure you have a backup strategy. Now, again, that will not keep you online, but stuff-ups happen. Mainly people happen. It is not hardware and software that tends to cause the problems. It's someone stuffing up somewhere. Sometimes they do it directly, sometimes they write a piece of code that stuffs up somewhere, but in any case, it's usually humans that happen. So logical backups and physical backups are really important. I personally don't really like physical backups because if any couple of bits goes wrong in the physical backup, so basically file copy, snapshot of your logical volumes, that kind of thing, you have a pile of bits that you can't do anything with. So a logical backup creates an SQL dump. And it can be a single SQL dump, or it can be multiple, one per table, one per database, whatever you like. But in the worst case, if something's stuffed up in there, you can load it in a text editor, you can remove the little bits that are junk, and you still have the rest. Or if you need to load part of it, it's actually quite easy to extract. You can write a little filter that does it, you can load it into an editor and search for it. You can actually make that work, and it's much easier. So they serve different purposes. For a file system backup, the purpose would be to reload it somewhere else much quicker. You can actually create an instance of your environment much quicker. And of course that applies to the database as well as for something else, like a Drupal install. We also use file system backups to start new replication slaves in a MySQL database environment. That's a cheap way of doing it. Okay? That's not the only way to do it, but it's one of the ways we do it. But I've mentioned replication now. Replication is not a backup strategy. If a mistake is made on the master, it is replicated, which means that all the slaves have the replicated problem. So if someone drops a database, it drops the database. So at that point you will need your backup, you will need something else. It is possible to run replication slaves in MySQL at a delay of 10 minutes, 1 hour, whatever you like, but that is only a window of opportunity. It doesn't actually necessarily prevent the problem. Sometimes you discover those issues later. So really having a backup that is separate from the rest of things is quite important. And now similarly, as I mentioned, everything will fail. And therefore a SAN or RAID array are not backup strategies. By the way, if you're making notes, I'm quite happy to share the slides for this, but anything I'm telling you that's not on the slides, of course you'll want to scribble. So I've been talking to many hosting providers in my years of doing this stuff, and a few have told me that their SAN can't fail. Yeah, who here in this room believes this? Okay, yes, we agree. It's nuts. They're crazy, and I think it's downright dangerous to try and sell me that kind of nonsense. It either means, well, it means something that I don't like. Let's put it that way. Either if they believe it themselves, they're delusional. If they don't believe it, they're lying to me. I mean, there's no winner here. And in any case, it doesn't help the client that actually needs to get something, because they're telling me something that doesn't benefit me directly. It's for their client who I'm working for. So it's just useless. We use something called MySQL with multi-masters. I'll get into that in a bit when I show you a couple of diagrams that give you an overview of what we do and how we do it. But the idea is that when a database server fails, that we actually have it fail over, and it can actually be automatic. We don't have to be there to make the change. The hosting provider doesn't have to be there to make the change, and you don't have to be woken up. If you want an alert about it, that's perfectly fine, that's possible, but you could check your SMS and go back to sleep, if that's what you want. I don't even want that alert. I know it works by now. And some of my clients used to want that alert, and now they don't give a toss anymore, and they just put the phone on quiet for that particular purpose. That works with Drupal 6, because one of the people that works for me, you may have heard of him too, Peter Lieverding, Cafuego Online, he has done a couple of patches in both core as well as a couple of modules in Drupal 6 to make it behave. There are some aspects to the multi-master system that make MySQL behave slightly differently, particularly with auto-increments, the sequence numbers inside MySQL. The installation of Drupal 6 relies on the system starting with row number 1. And depending on which server you end up connecting to, the first row ends up being row number 2. And of course that fails. But that was essentially a bug. So that's what Peter has fixed. It's perfectly fine. Replication slaves for readability is something that Drupal 7 just supports. Now I forget the name, but there is a, let's say, distribution of Drupal. Pressflow, that's the one, thank you very much. When I was just updating this, I forget it. So Pressflow actually allows you to do replication with Drupal 6 as well. So you don't necessarily need to be on Drupal 7. But that said, who here is already using Drupal 7? That's pretty, who here isn't using Drupal 7? Oh, you're vastly outnumbered now. Yesterday I had a 60%. This is like 90% or something using D7. That's very good. I have to admit, OpenQuery website still runs on D6. But it uses a lot of modules, and we've just been kind of waiting rather than jumping in. But I'd like to try as well. Let's see what replication does. This is the more technical view, just to give you a bit of an idea how MySQL replication works, because it's quite different from what some other database servers do. So any operation, so DDL is data definition language, and DML is manipulation language. Data definition is create table, drop table, that kind of stuff, alter table. DML is select, insert, update, delete. Okay? Those operations can get logged as SQL statements, and that is quite unique in the database world, to get logged statements rather than as row changes. But for MySQL 5.1 and upward, which you probably are using, you can get those row changes logged instead. You can also log a mix. Now, why did MySQL start using SQL statements? I'm not sure it was entirely on purpose. It seemed like an easier way to implement things at the time. It's actually worked remarkably well. Imagine an update or delete that affects 100,000 rows. And you have a replication system that is geographically distributed. It goes to another data center somewhere, or maybe even across the planet. MySQL with statement-based replication will be replicating a tiny string with the update statement. Other servers will be replicating 100,000 row changes. It's quite a difference. It works quite nicely. So MySQL can do row changes as well now, and there are a couple of reasons for that that are not relevant to this talk, but overall it actually works really, really nicely. So those changes get written into the binary log. What MySQL slaves do is read the log from the master, so a slave connects to the master, and it asks for what are the latest changes, and it grabs that stuff. If there's nothing more, it goes to sleep, and it gets a prod when there's something up again. So that's the rough version. Now, what does the slave do? It actually puts the information in its relay log, and then there's another thread that reads that information and executes. Now, there's a couple of lessons we can we can learn from that. Oh, and you can actually chain that, so the slave can also log the information. That can give you like a backup log, or you can actually have another slave connected to that. If you replicate from one data center to another, it makes sense to replicate it once to the other data center, and then have that slave be like a relay for the other ones. So you have a bit of a tree structure. We'll see that on the next slide, just to give you an idea. So the reason for having two separate threads is that if a query takes quite long to execute, you don't want to not read from the master at the same time, because you start falling behind. And that's what we found with MySQL 4.0, which first had replication. It couldn't keep up, so that's why there's now two threads. And there will actually be more threads in the future to parallelize execution for different databases. That's something that's being worked on right now. So what happens on a slave, all the changes that happen in parallel on the master do happen in series on the slave. There's only one thread that executes all that stuff. So there's a bit of a bottleneck there. So a common idea of I have a master that has lots of writes to do and I have slaves, I can just do cheaper hardware, lower specs, is not necessarily true. In theory, there's some exceptions to that, but in theory you should have a slave that's at least as powerful as the master, because it needs to deal with the same number of writes. It's doing with that in a single thread, which means on one CPU, on CPU core, it has to do the same as the master has done on many cores. And then, of course, it has to deal with all the readers, which is what you use all the other CPUs for. So in terms of memory and disk I/O and CPUs, it actually has similar requirements to a master, just to keep in mind, okay? This is a simple description of, or depiction of what MySQL can look like in a replication topology. And you can leave any of these bits out, it just gives you an idea of what's possible. So we have two masters, and they don't really care whether they're masters. A master is something that has a slave reading from it. And a slave is something that connects to a master to read from. That is the only definition that MySQL cares about, and it doesn't actually monitor those facts. So what we have with those two masters, they're essentially two slaves that read from the other one, which makes them dual masters. Does that make sense? Technically, you could call that a circle. You can do something called circular replication. You could have A replicates to B, replicates to C, replicates to A. That has been tried. The problem is that when one of those servers fails, gluing it all together at the correct positions becomes very, very awkward. So using more than two is pretty much something we never ever want to do anymore, because it's just a pest to maintain. Let's put it this way, it works as long as it works, and after that becomes a pest, which kind of defeats the purpose. So dual master actually makes sense. Now, any idea in the room why we want to have dual masters? Why actually do I want to have that kind of topology? What's the purpose? Redundancy, but in what way? What kind of thing do I want? So
high availability.
Okay, yes, so if one fails, I have the other one. Okay, that's nice. Can I also use it for load balancing? I hear a nod. How about I see a no? What do you think? Why not? Or are you just guessing?
You don't guarantee that writes will be over to the other master yet?
No, not quite.
Well, it's true redundancy. If one goes down, you've only got half your power. So
Yes, that would be a good one. Yes, if you're actually using it for load balancing and you need that capacity, then you can't do both. You can't have it both ways.
you're racing a car half throttle.
Exactly, which kind of, yes, you apparently are then underpowered, which is probably not what you want, unless that's an acceptable thing. But yeah, now the main thing is, as I mentioned just before, anything that gets written on the one side also needs to get written on the other side. Therefore, load balancing your writes is a completely moot point, because they still both have to do the same number of writes anyway. It really doesn't help. Of course, for reads, you can load balance. That's perfectly fine. But for writes, it doesn't help at all. Now, for reads, we have another method. They're called slaves. So yes, you could use a master and spread the reads across the two, but that's kind of an intermediate step that I'd like to avoid. I prefer having multiple slaves that do that. And as you see, you can hang any number of slaves from these masters. That works just fine. The relay slave there is used as an example of how we can get to another data center. It is not something we commonly do in a basic setup, because once you go to another data center, things get much more complicated, and that's not necessarily what we want. But having a separate slave for some reporting purposes, for some backup purposes, is perfectly nice. That works nicely. Okay, so steps that we take, and this is really the main story of my talk. What do we do in what order? Now you can jiggle around a bit with the steps here, and some you can actually leave out, but many of them you will get to at some point. If you really skip them, you may be missing out on either performance or the resilience that I talked about before. So one of the first things we do, and that's usually how we get to a client, is we get called and, well, our database is slowing down a bit. We've been growing a lot recently. Could you have a look? And of course, the server has been running for a fair time. They've just installed it, nothing special to it. And so what we do is we take a look on the server. We don't really have a statement of work that kind of restricts us in what we can figure out. It's like asking me beforehand, so which things are you going to investigate? You call a doctor and you say, I'm sick. Can you already tell me which things you're going to investigate before you've seen me? Well, I don't want to. I'm like a car mechanic. I start the car, I perfectly take it for a drive, so I want to see a production server, not some test system. And I'll listen to it, and maybe I'll figure out which bolt is rattling, and I know where that bolt is because I've got a bit of experience, and I do this stuff all the time. So yeah, I figure it out that way. So I don't define beforehand what I'm going to do. I just take a look around and I identify things and take it from there. So that's the way we work. We tune the server. There's a number of things we always do to the server. So again, that's kind of too detailed for what I'm talking about today. There's a number of settings we always adjust because the defaults tend to not be good enough in terms of logging, in terms of logging warnings, slow queries, that kind of thing. But one of the main things that we also like to look at, and one thing we often suggest, is to move from the default MyISAM database storage engine to the InnoDB storage engine. Now, even though the base Drupal doesn't use transactions, InnoDB still gives benefits. MyISAM, with the proper configuration, is pretty crash resilient, so that is not really an issue. But in terms of performance, when you have quite a few updates and writes as well as selects, that's when InnoDB, given sufficient tuning, starts performing better than MyISAM. So MyISAM, contrary to popular belief, is not only good at selects, it's actually good at selects and inserts. And the reason for that is that it's actually a data warehousing engine that the project was built for, and it's actually very, very good at it. So it does remarkably well considering the generic workload that we put on it these days, but InnoDB is better at it. It can do selects without doing any locking whatsoever. It just sets little flags so it knows what it's doing. So we can also take backups, and that's really important. We can take backups without any locking. Sounds rather nice, doesn't it? So we don't necessarily need to take a server offline to take a backup. We don't need to lock anything. We actually need to throttle, if we use MySQL dump for this, we actually need to throttle the I/O. We use I/O nice to tone it down because the disk I/O that the dump generates tends to, let's say, sabotage the server. Little internal denial of service attack. So we have to throttle it with I/O nice to make it go slower, but that's fine because it's not locking anything. It takes a consistent snapshot. So it starts a transaction and it takes a consistent snapshot of all the tables and all the databases, and that's how it does its job. So it's actually one of the nicest possible backup logically, and it does that without particular trouble. So that's one of the reasons for InnoDB. There are others, but this is just a basic idea. However, it needs to be tuned properly. If you just convert all your tables to InnoDB, InnoDB will behave much worse than MyISAM when your database server is untuned. And believe me, if you've just got a default install of MySQL, your database server is untuned. It is suitable for use, but it's not really suitable for production. So who here runs with the default install that hasn't been changed? It's not that many. So who here has done some minimal tuning? Many more. Who here has done lots and lots and lots of tuning? There's a few again. One of those nice curves. This is the regular stuff. Okay, so that's the baseline of what we do. It just makes sure that if we don't get to the rest anytime soon, then at least we've got something. We usually take about 4 hours to do that, and in those 4 hours we also identify other things that we want to work on. And we discuss those things. We discuss them before we take steps with the tuning. and then we implement a couple of things that are the most important according to us in agreement with the client. So that's how that works. If the client says, okay, I only have 2 hours to spend, that's perfectly fine, then we do what we can in 2 hours. It's just 4 hours is an indicative thing. One of the first things we do when we actually get the chance and the budget and so on, and the time, is split the web server from the database server. Why might we want to do that? Any thoughts? Yo. What's that?
Disk load?
Disk load? Yeah, possibly. That's one reason. Others? Memory, yeah. For me, that's actually the main one. If you're using Apache loves memory. Lots and lots and lots of it. And what does MySQL like? Lots and lots and lots of memory. So trying to keep an eye on both and keeping them both happy tends to not happen. Like RAM is cheap, but there's always a limited supply. So sticking them on separate database servers is a good start. Yes, Jake?
I was just going to say, why put more RAM in if you can?
Yes, putting more RAM if you can, definitely a good idea. But I still want to separate, and I'll get back to the why. I should mention, which I didn't mention here, who here runs on 32-bit VMs? Too many. Should be 0. There's absolutely no excuse for a hosting provider to not provide 64-bit VMs. Some of them still use it as a business thing. You get a cheaper VM 32-bit, and then if you want some serious stuff, then you get this enterprisey 64-bit that you pay much more for. It's complete bollocks. It just makes no sense whatsoever. It should be 64-bit. There's a very good reason for wanting 64-bit. Apache doesn't care. It's multi-process. It can address 3 gig or whatever it is in each process. MySQL is a single process and then multi-threaded. So if you're running in 32-bit, it can address only 3 gig. That's it. So that means that you can't actually tune the server properly, even if you stick in a huge amount of RAM. And that's a problem. Okay? So if you split the system and you have a 32-bit box, leave the web server there and start the database server on a new machine. That works perfectly fine, and that new machine should be 64-bit. Now, we often tell hosting providers to install 64-bit. We tell them, we remind them, then we ask them to make absolutely sure, then they deliver it, and then we send them back to do it again. This is just the typical way of going it, and I'm not just being negative here, this is the way it works. It's really, really sad. They still install 32-bit because they think that that's the way things work. Things might not work on 64-bit. At some point along the line between us telling them and them delivering, some smarty pants thinks that they know better. They may know for many cases, but for MySQL servers, it's a really, really bad idea. It is not necessary. Any Linux of recent years will do perfectly fine. And even on Windows, 64-bit Windows will work better for MySQL. Again, it can address things better. So splitting. I'll explain in a moment why we've split, because we'll get to that in a separate stage. But not having conflicts in terms of RAM, CPU use, disk I/O, that's just a convenience along the way. The next thing we would do is start using tools like memcached, Varnish. So Varnish sits on the front end and just make sure that fewer things go to your web application server and to the database. That's nice. Reducing the number of queries is always a good thing. Because the query that you don't run, of course, is faster than the query that you do run. Now, that seems like a bit of a cop-out. Yeah, it's, the cheapest query is the one you don't run. It seems like a bit of a cop-out. What's the database server for running queries? But just to give you an idea, let's say you're running this enterprise company. How many employees do you have? Give me a number. Big enterprise company. No, that's not enterprise. Come on, do better than that. Let's say 100,000. Okay, you've got 100,000 people. Okay, so at some point, maybe if they're all in the same time zone, you'll have 100 some or same set of time zones, West Coast, East Coast, US, whatever. You have 100,000 people logged onto that database server. That's a fair number. Okay, now how many concurrent users does Facebook have? Yeah, now is Facebook an enterprise application? Should be. Thank goodness they're not. Because if they actually followed the rule set that the enterprise companies think they're supposed to be using, it wouldn't work. It really doesn't work. The concept of enterprise works fine. If you look it up on Wikipedia, the idea about enterprise design works perfectly fine. The way it's implemented is business processes that essentially reduce the amount of movement that happens and everything is controlled. And by the time you have everything managed like that, nothing happens. It's very predictable. but it doesn't scale. So that's a very serious problem. So forget about the word enterprise. Whenever you see it, whenever someone tries to sell you enterprise, run a mile and tell them to stuff it. Really, it is not a good idea. So things like varnish, it helps because reducing the number of queries is essential. You can't scale by chucking everything into the database. In the end, that is your bottleneck. That is the thing with the fewest number of servers. You have more web servers than database servers once you start scaling. And of course, there's more browsers on the client end than there are web servers. It scales out. It's like a big tree. So you want to move things as far out as possible. If a client can avoid doing a query, that is better. Okay? So apart from varnish, memcached. So caching entire blocks, as in Drupal blocks, is a good thing. That is brilliant because many of them don't change all the time. So you use the appropriate Drupal model to stick that to memcached or something similar. I know that there's other tools that do similar things that are not called memcached. It's that idea, okay? Now, full text searching. There's two reasons to actually install that appropriately. There's a Solr module for Drupal so that you can actually use that nicely. There's also a system called Sphinx Search which works well, really well together inside MySQL, so you can use either. The two reasons are databases are hideously bad at full text searches. Okay? So doing something special for it, if you allow searches on your website, in your Drupal site, that is important because it will just become slower and slower. Now in MySQL, the full text system is attached to the MyISAM storage engine, which we've just got rid of 2 steps earlier. Okay? So some of your tables may now still be full text because that conversion to InnoDB couldn't be completed. We haven't got Solr yet. Okay? So now we move to Solr, get rid of those full text indexes, convert those tables to InnoDB, and things will just run much nicer and quicker. Okay? So having a single storage engine rather than a multiple works much nicer. So that's why we have that Solr system. So it works faster as your data set grows. Of course, on a development machine, your full text index on MySQL will work just fine. When your data set grows with lots of users, it will really, really slow down your system. With more data, both the inserts and the search queries will become much slower. So we don't want that. Backups, I've mentioned before, at some point along this line, we do want to set up that backup environment. It is not always the highest priority because in some cases the site is doing so badly that the users are actually getting upset. So we need to fix a couple of other things first, but not touch too much, and then we get to backup steps. So that's why I didn't put it in step 0.5. That would be nice, but it's not always feasible. So that's why it's slightly lower down. Now, then step 4 is we go from a single database server to dual masters. And that, for me, is one of the main reasons why I split the web server from the database server. Once I've split them, I can actually duplicate the individual parts. Does that make sense? Because having a second database server while the web server is still sharing the same host, then what happens to that web server when the database server fails? When the whole machine fails, I still lose my web server. It could connect to the other one. If it doesn't fail, it becomes a mess. So separating that in separate VMs is nicely, or separate physical machines. So we get to the dual master system. The dual master system that we use uses something called a floating IP address, a virtual IP address. So it's an extra IP that flips between the two servers and it gets controlled by something called MMM, MySQL's Multi-Master Manager. So it's a tool that keeps an eye on all the systems, including the slaves, and it moves the virtual IP address. So it relies on a hosting provider that can do that. Amazon, for instance, cannot. It has something called Elastic IP, but it gets charged at data center external rates. You actually get charged for internal traffic because it's a floating IP address. Not cool. We use Linode quite commonly now, and Linode can do this just fine. There are other hosting providers that can do it as well. I'm just giving one example. So once we get the dual masters, things become much more convenient. We can actually upgrade a MySQL server or the whole machine. If we need to do a Linux upgrade, that can all work. We can do that without taking the system as a whole offline. We can add an index on a big table, which would normally lock that table for the duration of the index of the table being rebuilt. So that works quite nicely. We can do all kinds of things with dual masters, just as a management convenience that are not even related to the failover and resilience system. So we get lots of extra benefits from that. Monitoring and trending, really, really important. Now, when we work under a subscription model, we log into those systems regularly, keep an eye out for things, and we kind of notice certain variables suddenly looking slightly different from what they looked the last week. But you can also track that kind of things using monitoring tools. But you don't want an alert on a certain threshold. You want to see a graph over time. What happens with MySQL is that the performance degradation is not gradual. It goes down a little bit and then it plummets because you will hit the capacity in a certain cache. And once it fills up, it drops dramatically. Does that make sense? So if you wait for the thing to drop, that's an emergency. You don't want to get there. You want to see the trend. So once it starts dropping a little bit, that's when you want to catch it. So that's the kind of thing we want to monitor. There's a number of tools for that, and I'll mention one or two along the way in a moment. We don't have much time left. Almost 5 minutes, right? Yeah. Okay. Security and penetration testing. You can think that's an optional extra, but it might not be. You know, in essence, any publicly facing web server is, you may regard it as potentially breached, because there will also always be some bugs in Apache PHP, you know, that haven't been caught yet. Just a matter of time. So keeping an eye on those things, particularly if an e-commerce site with lots of client details, it's something you want to get tested. We have people to do that. You can also get someone else to do that, but someone needs to do it, and they need to not be connected to you, because even if you are good at security, you need someone who hasn't been staring themselves blind at your particular infrastructure. You need someone with a fresh look, which is very healthy. They need to be nasty in a good way, you know? Puppet, excellent for deployment and keeping servers consistent with each other and starting up an extra server, you know, that kind of jazz. Not all systems need it, but many of our clients, even if they're tiny, now really benefit from that kind of setup. We have quite a few of templates, quite a few Puppet recipes for this now, and it actually works nicely. So every new client where we do something, we actually we can build on that, and we can do that quicker now. It is something you probably want to outsource, because getting into the Puppet system, unless you have a heck of a lot of time, it takes a little while. We often move from Apache to Nginx. Opinions differ, and Apache can work fine, but we like Nginx better. We find that it's easier to control the system. It can be faster, so for capacity as well as overall performance, we like it better. So we can control what happens when. When necessary, we might want to go from single web server, which we split up in step 1, to multiple web servers. That creates redundancy. If one fails, you can use the other. But you could also have load balancing. So you can have 2 web servers, you can have 3, you can have 10, whatever. And you can also dynamically scale it. You can say if the load is more than 80% on each, then start up a new one. You can do that in systems like Linode or other mini clouds. MySQL slaves. Once you have dual masters, dangling a couple of slaves off the system becomes very easy. The slaves also get monitored by the multi-master system. They always get attached to the active master, just to be sure. And the system also keeps an eye on whether they're behind or not. If they get behind or not, their IP address gets taken away and attached to one of the others. Now that is not really load balancing, but at least it prevents the system from talking to a server that has been falling behind. Falling behind is not offline, and that's a problem. Yeah. So not properly online is a different thing when you're talking to a MySQL slave. It can be perfectly responsive, but 5 minutes behind in replication. You should normally have that, but it's possible. So you need to keep an eye on that and have the infrastructure to deal with it. In some cases, we've been asked for cross-data center failover. Now, I've tried it, I never do cross-data center live systems anymore. The latency between the servers is just too much unless you have some nice low latency fiber between them. So what we can do is set up a couple of servers, let's say a minimum setup of what we have in the other points. You set that up on the data center. It replicates from the first data center in a chain, because you can't have dual masters. A MySQL server can only talk to one master. So you kind of get a chain in the other data center, and if there's a failover, you kind of manually decide to do that. And that then becomes the primary data center. So there's no main and a backup. You have 2 main ones, and the other one, the second one becomes the main one when there's a failover. Yeah, I think that's it. So this is, in short, an overview of the kind of tools we use. We prefer MariaDB, which is kind of like a fork, a downstream fork of MySQL, made by the original author of MySQL, Monty, and most of the optimizer team from the original MySQL, so we like it better. MySQL MMM, we like MaatKit, which is now called the Percona Toolkit. It helps us detect whether a slave is out of sync, and well, whether it's out of sync, and if it's out of sync, we can actually rectify that using the Percona Toolkit. It's actually quite a nifty tool. We use Zabbix for monitoring and trending. That doesn't mean you have to use Zabbix. It's just one example of the many tools that are there. Memcached Varnish and ZenX I've used. We like Ubuntu and Debian, but if you like CentOS or Red Hat, that's perfectly fine too. For remote management, we find Windows an absolute pest. But if you have your local Windows servers and you're a skilled Windows administrator, it can work perfectly fine. PHP works really well on Windows now because Microsoft has actually put extra effort in, and good for them. MySQL on Windows works really well as well. So that's all good. Puppet, BZR Mercurial, all those things are very, very useful to just keep an eye on things. And Linode, as I mentioned, for our perspective, it deals very well with the kind of infrastructure that we use. Many relatively smaller servers that actually only cost a couple of $dozen a month. You have more of them together rather than spending thousands of dollars on a SAN with big VMs, you know, the kind of stuff that the hosting provider will try to sell you. That is not what keeps your server running. Okay, just one or two questions, I think, then we're out of time. Okay, yes?
I think your title of this presentation had the word affordable in it, but it
Yes.
sounds to me like you want to throw as many servers as you can.
Yes.
Can you explain how the affordable part comes in?
Because each of those servers own, okay, I'll echo the question, yes. The question is, okay, in the title it says affordable, but in the story I kind of refer to many servers over time. How does that remain affordable? Each of those servers actually doesn't need to be that powerful. They may cost anything between $20, $30 and $100 a month, just to give you an idea. They don't cost thousands. So when you're looking at bigger hardware, you're usually looking at hundreds of dollars for an individual system. So if you kind of split it up in that way and you then scale it back out, this is actually cheaper, and in any case, it serves the purpose, whereas the other one doesn't serve the purpose. So if you actually require the resilience and the scalability, even if you do it very minimalistically, this is about the same price, and when it scales, it becomes much cheaper. Does that make sense?
Linode's pretty good for that.
As an example, Linode is pretty good for that. And we like Linode because they've been proving over years to be reliable, clueful. I've never actually had to ask for another engineer with more clue. They've always come back with a sensible reply. I've even had to move servers to another physical location or another data center. They just set it up, you press a magic button, it just happens. If it's not already in the web interface for you to do, it's bloody brilliant. So there are others that are really good. For instance, Rimu Hosting, based in New Zealand, but they have data centers in Brisbane and Sydney. They're also really good. They cost a bit more because they're based here. Yeah.
What was the name of that?
Rimu Hosting, RIMU Hosting.
Okay.
Okay. Yes.
I think you might have just touched on what I was going to ask, which was locally situated data, equivalents to Linode.
Yes.
In terms of which one you use for latency, like what do you find's best? The Japanese one that's just opened up, your comments on that?
Okay. For our own infrastructure, we're actually waiting for the Tokyo data center of Linode to complete its IPv6 testing because we're completely dual stack and I'd like to keep it that way. So I'm waiting for that to be completed, which may have just happened. They've been working on it for a few months. So yeah, I think that's the best one so far. There's also a London one, but I think Tokyo's closer to us. I wish they'd open something in Australia, that'd be great. But yeah, I know. But look, there are decent Australian providers, but inevitably you pay more just because of the way the Australian pricing with data works. So it's just a matter of taking care. What we tend to find though is that the big fish in Australia tend to not really cater for what you want. You get things like beautiful SLAs and promises, but that's not really what you need to make it work. The enterprise blah again. So, okay. Okay, last question. But feel free to catch me outside. I'm here until tomorrow afternoon.
What's the story with Drupal 7 and multi-master at the moment? Does it just work, or
it should just work?
Should
yeah.
just work.
Well, that's a bit vague. As far as I know, it works. I don't have Pete here to back me up, but yes, I haven't heard it from not working. I haven't recently tested that myself, so yes, I have no indication whatsoever that it might not work. I could be in politics, yeah. Okay, thank you all.